Have you ever need to rename 50 crash tests in Navisworks and realize there is no batch rename? Navisworks forces you to rename crash tests one by one. There's no multi-select, no find and replace, no bulk edit, nothing. And if your project have 30, 50, or hundreds crash tests that all need a standardized naming convention, it's the kind of task that make you question your career choice. Hello, I'm Clemar, and I'm here to show you just how fun and easy it is to create your own riff plugin on Navisworks software using Python, even if you never write a line of code before. Watch this. I built a Python script that solves this exact problem. You export your crash test from Navisworks as an XML file. You run the script. It's ready every single crash test name and lay them out in a clear Excel spreadsheet. Now you're in Excel, the tool you already know and love. You can use find and replace, drag fill, copy paste, apply your naming conversion across hundreds of tests in seconds. When you're done, save the Excel, run the script again, and boom, it generates a brand new XML file with every name updated. You import that back into Navisworks, and every single test is renamed. The tool on the left is my Pro add-in, which is used by the professional and those without time to code. It's built with the modern interface, but you don't need to be a pro developer to get the same logic. Today, I'm going to teach you how to build a Python version. It has the exact same automation logic, just wrapped in a simple interface. Perfect for learning. I've done the hard work for you. You don't need to type a single line. I have prepared the Google code on my GitHub. Just download, copy, and paste. You have completed your own software before you even start. The code works perfectly, but if you're a big manager running a business and you just want a done-for-you installer with the modern UI and undo safety net, you can grab the Pro version instantly by supporting me on my website. It saves you hours of setup and keeps these channels alive. But if you want to understand the logic behind the magic, let's look behind the scene. For block 1, it is the toolbox for the import and setup. From line 1 to 10, every Python script starts by opening its toolbox. Think of imports as walking into a hardware store before a renovation. You grab exactly the tool you need before you start working. XML.e3.element3 This is our XML surgeon. Element3 is Python's built-in element for reading, navigating, and modifying XML file. Navisworks export its crash data as XML, so this library lets us open that file, find specific tag like crash test, change their attribute, and save the result. We aliased it with ET because we will call it constantly, and typing element3 50 times would be painful. Open PyXL in line 5 to 6. This is our Excel factory. While element3 handled the XML side, OpenPyXL handled the Excel side. We import the main module to create and read Excel workbook, and we also put in 3 specific styling classes: pattern fill to color cell background, font to change text color and boldness, and alignment to center text. These aren't strictly necessary for the logic, but they transform our raw data dump into a professional, user-friendly spreadsheet, especially when you are handling this file to a colleague who have never seen Python output before. For the OS in line 7, the file navigator, we use os.path.exist to check if file actually exists before we try to open them. os.path.splitText to separate file name from their extension, and os.path.decname implicitly through our path operation. Without OS, our script would crash the moment someone pointed it at the missing file. For the sys at line 8, the system communicator, import here for potential command line argument handling and system level exit call. Even though this tutorial version primarily used the GUI file dialog, having sys available is a good practice for extend the tool later. For example, accept drag and drop file path while sys.argument. Tinkta at line 10, the window builder, we import three specific components. File dialog, which is used to open the window file picker, TK, the wood window object, and message box for success error pop-up. We are not building a full application Windows here. We are using Tinkta as the lightweight notification system. The user never see a window from our script. They only see the file picker and the result message. For block 2, it is the namespace registration. This single line is easy to overlook, but it's absolutely critical. Think of this as a passport stamp. Navisworks XML file contains namespace declaration. This XML was created according to a specific standard. When Python element trees read and then rewrite an XML file, it has a nasty habit of mangling those namespace prefixes. It may rename XSI to NS0, which looks different to Navisworks and can cause the import to fail silently or float an error. By registering the namespace before we place everything, we are telling Python, when you encountered this namespace URL, keep calling it XSI, not some auto-generated garbage. This one line is the difference between a file that Navisworks accepts and a file that Navisworks rejects. For block 3, it is the engine, the crash renaming class, from line 24 to 28. Here we define the crash renaming class. It functions as an individual tool. A class is an entire workstation. Its bundle related tools together with the material they operate on. The int method is the setup phrase. When we create a new crash renamer object, we hand it to the path to our XML file and initiate two empty slots, self.tree, which will hold the entire XML document structure, and self.root, which will hold the top level element. We don't load the file immediately. We wait until someone explicitly called load XML. This is called lazy loading, and is a defensive pattern. If the file path is wrong, we want to handle that error gracefully in a dedicated method, not in the constructor. From line 30 to 41, the node XML is an ignition key. It does three things in sequence. First, existence check at line 32. The os.path.exist acts as a bouncer. If the file doesn't exist, we return false immediately, instead of letting Python throw file not found error deep inside element tree, where the error message will be confusing. Second is the praising at line 35. et.praise with the entire XML file from this and build an in-memory tree structure. Think of it as converting a physical blueprint into a 3D model you can rotate and inspect. The self.tree object holds the entire document, while self.root gives us the top-level element, the front door of the XML structure. For the third, error wrapping, at line 34 to 41. The entire operation is wrapped in a try-except block. XML file can be malformed, just like missing closing tag, encoding issue, corrupted byte. Instead of crashing, we print a diagnostic message and return false. This is our safety net. The script degraded gracefully instead of exploding. For the block 4, the exporter, the XML to Excel, from line 43 to 84. Export to Excel is the translation layer. It reads the machine-friendly XML and produces a human-friendly Excel spreadsheet. Lazy load guard, the first line check if not self.root and not self.load XML. This is a double check pattern. If the XML hasn't been loaded yet, it tries to load it. If loading failed, it exits. This means you can call export to Excel without worrying about whether load XML was called first. The method protects itself. Workbook creation at line 49 to 51. We create a brand new Excel workbook with OpenPy Excel.workbook. Grab its default active sheet and rename it to crash name. This sheet is our canvas. the header row at line 54 to 63. We write 3 column header, ID, which is the not edited one, original name, and new name. Then we style them with a blue background and white bold text. It's visual communication. When your colleague opens this file, and the column names tell them exactly what to do. The extraction loop from line 66 to 75, this is the heart of the exporter. The self.roots.iter is an XML crawler. It's walk through the entire XML tree and find every element tagged crash test. For each one, we extract the name attribute using .getName. We write 3 columns per row. Column A get the index number I. This is our invisible anchor. It's linked the Excel row back to the exact XML element. Column B get the original name, which is for reference. And column C get the original name again, as starting point for editing. The user only need to modify the column C. For the column formatting at line 78 to 81, we hide column A entirely. Why? Because column A contains the internal index that our import function needs to match Excel row back to the XML element. If a user accidentally added or deleted an index, the entire import breaks. By hiding it, we make it invisible but still accessible to our code. This is a safety guards pattern. Protect critical data from human error by moving it from view. For the block 5, it is the importer. Add the Excel back to XML at line 86 to 100. From the import from Excel is the reverse translation. It reads the user edited from Excel and stamp them back onto the XML. For building the rename map at line 91 to 100, we load the edit Excel file and iterate through every row starting from row 2, skipping the header. Each row gives us 3 values, the index, the old name, and the new name. We store these in Python dictionary called rename map, where the key is the index and the value is new name. A dictionary is perfect here because it gives us an instant lookup. When we are scanning through an XML, we can check does index 7 have a new name in constant time, regardless of whether there are 10 or 1,000 crash. The replacement loop at line 102 and 107. We iterate through the XML crash test element against using the same enumerate and iterate pattern. For each element, we check its index exists in our rename map. If it does, we call crash test.set. This is the XML surgery moment. The .set method modifies the attribute directly on the in-memory tree. We also increment updated count so we can report how many names were actually changed. For saving the result at line 110, the self.tree.write serialize the entire modified tree back to the disk as a new XML file. We specify encoding equal to UTF-8 and XML declaration equal to true to ensure the output file has the proper version that Navisworks expects. Critically, we write to the new file, not the original one. This is a non-destructive editing principle. The user original export is never touched, so they can always go back if something goes wrong. Block 6. The controller. Application logic and file routing. On line 114 to 155, the main is the traffic call. It decides what happened based on what file the user select. Window setup. On line 116 to 117, we only want a file dialog, not a blank window sitting on the taskbar. File selection. On line 119 to 126, the file dialog asks open file name. Open the standard window file picker. The router. On line 132 to 152. This is the decision engine. We extract the file extension using the os.path.speedtest and branch. If XML, we are in export mode. We create a crash renamer pointed at the XML, call export to Excel, and show a success message. The output Excel file gets the same base name as the XML. If it is an Excel file, we are in the import mode. Here's the clever part. We assume the original XML has the same base name as the Excel file. So if the user select mycrash.xml, mycrash.excel, we look for mycrash.xml in the same folder. If it's missing, we show an error immediately. If it exists, we create a crash renamer pointed at that XML. Call import from Excel and save the result as mycrashrename.xml. The naming convention is the invisible contract between the export and the import steps. As long as the user does not rename or move the file between the steps, everything line up automatically, is simple, predictable, and requires zero configuration. Next, it is the error wrapping on line 154 to 155. The entire routing logic is wrapped in a try except block. If everything unexpected happens, just like a corrupted Excel file, a permission error, or a disful scenario, the user sees a clean error dialog instead of a Python trackback. This is the file safety net that makes this a tool, not just a script. Entry point on line 158, the if name equal to main got ensure that this code only run when executed directly, not when imported as a module, as a Python best practice that costs nothing and prevent accidental execution. Today, you build a custom tool, complete with UI and logic. You can now automate this task in seconds instead of hours. With this tool, you can avoid repetitive tasks and start automating your workflow. No more manual clicking buttons. But I also know many of you are busy fighting deadline, meeting client pressure, or debugging error. Just try to set up an automation. That's exactly why I created the pre-built one, a professional version of everything we built here. You can use it right away, with no manual setup, no code error, and no admin right. And experience what this automation feels like when they run at full speed. It's not just a shortcut, it is a motivator. Once you have tasted what the supported version can do, you will be inspired to learn how it works under the hood. For supporting me, you help me creating free, high-quality tutorial for everyone, while getting the polished, professional version for your daily work. You can join via my official website, links are in the description. Every bit of support keeps these channels alive, so together we can make Rivet and the visual automation easier, faster, and more accessible to everyone. Before you go, what's the next boring task you want to kill? Drop your idea in the comment. Your idea will become the next video. Let's build smarter, not harder. I'm Clemar. See you in the next video.